Hello students, welcome to the video lecture series of data structure. Our today's topic is DQ, that means double-ended queue. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today we are going to learn about the DQ, the insertion at front, insertion at rear, deletion at front, deletion at rear, and then the example of DQ. So let's start with the first concept to understand that what do we mean by DQ. Students, if you know the in Q we have only two ends. The one end which is used for the insertion and the second end which is used for the deletion. The end which is used for the insertion is known as rear and the end which is used for the deletion is known as front. But what if you can do insertion and deletion both operation by using rear end? You can do insertion and deletion of both operation by using front end. So that concept is known as DQ. DQ is further divided by into two different parts. One is input restricted DQ, second one is output restricted DQ. So let me show you what do we mean by exactly DQ. So DQ is a more generalized form of the Q data structure which allows the insertion of an element or the removal of an element from the queue from both ends. The types of the DQ, the number one is input restricted and number two is output restricted DQ. So here it is. If we talk about the input restricted and output restricted, so the first figure shows the DQ generalized form where you can do the insertion, you can do the deletion of the elements from the both ends. The both things are known as the input restricted and output restricted. In input restricted, students, at the one end, you cannot insert the data elements. On the another end, you can do insertion deletion both. In output restricted, on the other end, you cannot delete the values, but you can do insertion deletion at the one end and insertion at another end. So that is known as output restricted and input restricted DQs. Now, let's move towards the very first algorithms. See, if we talk about the DQ, students, you can perform the four different algorithms in DQ. One, insertion and deletion at front end. Second, insertion and deletion at rear end. So here what we have, the number one is insertion at rear end. Number two is insertion at front end. See, the insertion at rear end. Let me tell you that in the simple queue, what we did the same thing because the simple queue insertion is known as insertion at rear end. Okay, I used to say this that you can do insertion only at the one end and that end is known as rear end. So here when we talk about the insertion at the rear end, the algorithm is totally similar as simple queue insertion. The different algorithm is all about the insertion is at front end. But same like that, students, when we talk about the deletion at front end, it is same as the deletion in simple queue. But when we talk about the deletion at the rear end, yes, definitely, it is little bit different. Fine. So let's first take a quick review about the very first algorithm that is known as simple queue insertion, or we can say insert at rear end. See, this is a double queue insertion or double queue insertion at rear end. That's why my naming convention for the function is little bit similar to the work of the algorithm. Okay, you have to be practice for this. You have to make sure in a program, in any programming language, the function name must be meaningful as per the work will done by the function. Okay, so here this algorithm or this function is going to perform the WQ insertion, or I can say the WQ insertion at the rear end. Okay, so here it is. My function name is ins at the rate rear end insertion at rear end. What I need I need front, rear, and q y. Fine. So the steps are the common, same as the previous one. If my rear point is greater than equal to n, then it must be overflow. Here I am going to perform the insertion operation from the rear end. That's why, student, I need to compare the rear end only. Now the next we have the increment the rear pointer. Increment the rear pointer, that means r is equal to r plus 1. The next, assigning the value, that means q of y is equal to q of Q of R is equal to Y. And the next one is, if my front pointer is at 0, then make it at 1. So this is as simple as the simple Q insertion. I'm not going to say anything brief about this because you already know about it. Okay, if you still do not aware about the simple Q insertion, then check out the video of my simple Q insertion, how it works. Now, let me tell you, the next one is insertion at front end. See, this is little bit different. Usually what you are doing, you are inserting the value from the rear end. But here the algorithm told you to insert the value from the front end. That means you obviously do something weird because it's not a simple queue, this is a double-ended queue. So as students, you know, in the rear end insertion, you are incrementing the rear pointer. In rear end insertion, you are incrementing the rear pointer. In the front end insertion, you should decrement your front pointer. See, if this is my Q, if this is my Q, if I'm talking, sorry, if this is my Q, if I'm talking about this particular Q, okay, and this is my rear end, this is my front end, okay, my insertion goes like this, insert the values, deletion goes like this, deletion of the values. So when I want to insert something at the front end, students, you need to decrement your front pointer. So my insertion goes in this direction, my deletion goes in this direction. Fine. So let me show how it works. So the function name is, sorry, algorithm name is procedure ins @front and frqy. Then we'll check out about the overflow condition. See, when the queue becomes overflow, let me tell you. See, in the rear end insertion, if this is my queue, this is 1, 2, 3, 4, and 5. If my rear move towards the 1, 2, 3, 4, and the 5th position, that means at the end, my queue becomes overflow. But when we talk about the front end insertion, if this is my queue, students, what happens? See over here. If this is my queue, then my front pointer move towards the decrementing. If it is 2 second position, move towards the 1. If it is third position, we move towards the 2, again decrementing at 1, again decrementing. Is there any place? No, because your queue is from 1 to 5. You cannot decrement the front pointer before 1. You cannot go to 0. That means your limit is at 1. You cannot decrement your front pointer when is it at 1. That means if your front pointer is at 1, it becomes overflow. Fine. So because you are inserting in this direction, you are inserting some elements in this direction. Okay. So this is the insertion in the rear end in this direction, a simple Q insertion. But when you are inserting here at the front end, you are going into this direction. Fine. So this is how the insertion occurs at the front end. So this is my Q 10, 20, and 30. My front pointer is pointing at the 1. That means you cannot decrement the front pointer more. That means you cannot insert any value in the front pointer. The condition for the overflow is, if my front pointer is at 1, you cannot do any insertion. You can directly move towards the return. Next, if it's not like that, that means the first thing, if my front pointer is at 0. Students, when my front pointer is at 0, when my queue becomes empty. Okay, so when my queue becomes empty, my front and rear both are at 0. When my queue becomes empty, my front and rear both are at 0. That means I should move both to the 1 and assign the value. Again, I should move both to the 1 and assign the value. So here I am going to write that if my f is equal to 0, then students, you need to write f is equal to r is equal to 1 and q of f is equal to y. See, q of f is equal to y. But wait, this is a situation when you can directly insert a value when your queue is empty. But what if your queue is not empty? Okay, so the situation is that when your queue is not empty, then you just need to decrement a front pointer from here to here and assign the value q of f is equal to y. So this statement q of f is equal to y is a common in both the situation. That's why I'm going to write if f is equal to r, if f is equal to 0, then f and r both pointing to the 1, else f should be decremented. So after resetting the front pointer value from 0 to 1 or decrementing, we just need to assign the value q of f is equal to y. Students, Here you can see the q of f is equal to y because we are going to insert the value at the front position. Remember, do not write q of r. You should write q of f only. Fine. Now let's move towards the next. So here is the example of the front end insertion. See, by default the queue is empty. So insert 30. See, I am inserting the 30 directly at this position. I am showing you this example. There is nothing like a magic that you can directly insert 30 at the third position. Okay, I am just showing you to elaborate the example of front end. Okay, so just imagine a situation that you have one queue initiated with the 30 value which is at third position. Okay, this is my queue, 30 value is at third position. Now if I want to insert something, insert 20, insert at front is there, so front will be decremented, it goes at the 2, it goes as a 2 and it will be assigned the value next, that is 20. If I again want to insert something, 10, it will be assigned the value, front will be decremented and 10 will be assigned to it. If I want to again move towards the there, insert 40, can I do that? No, because my front pointer is already at 1. You cannot decrement more. So that is Q is full. This is the whole example of insertion at front end. Fine. Now let's take a next example. So students, let's take a next example which is deletion at front end. Deletion at front end, which is similar as the simple Q deletion. I'm not going to go in deep for this. So here it is, students. The thing is known as the deletion at front end. The parameters are q, f, r. Okay, first into check the underflow condition. If f is equal to 0, then just write the q is underflow and return 0. Then step number 2, if it's not like that, then assign the value q of f to y. Q of f to y. We're just assigning the value q of f to y, and then what to do next? See the next step. Okay, so when after assigning the value q of f to y, we just need to check whether my front and rear both are at the same position or not. If both are at the same position, students, then you just need to move f and r to 0, and else just increment the front pointer value. So here it is. The last step will be return y. Fine. So this is how you can perform the deletion operation in DQ when the deletion occurs at front end. Now let me tell you the next deletion operation, little bit here, which is known as deletion operation at the rear end in DQ, because we usually do the insertion operation, right? But here I need to do the rear end. So this is my Q, students. If this is my Q, when I want to delete something, my rear is here, my front is here, I just have to increment my front. See, increment my front from here to here, here to here, here to here. In this direction, we are going to delete in a simple Q. Okay, but this is DQ. So deletion occur at the rear end will goes like this. Decrement the rear, decrement the rear, decrement the rear, decrement the rear. So it goes in this direction. Fine. So just check out the algorithm. The first, how you can see that your Q is empty when your rear pointer is at 0. See, in the previous algorithm we have written like that f is equal to 0, but here I am going to write rear is equal to 0. Why? Because this is deletion at rear end, and as far as I concerned with the rear end only. Okay, so here the rear is equal to 0, then you should write your Q is empty and return 0. Else, what to do? If this is your front, you need to assign the value of q of r to y. Here you need to assign the value of q of r to y. So after assigning the value of q of r, your rear will be decremented like this. Here will be decremented like this. Okay, so when your f and r are at the same position, students, again the situation is same. Both pointers move towards the 0. Else, what to do? Else, just need to decrement your rear pointer. So the condition remains the same, that if f is equal to r is equal to 0, f is equal to r, then just move towards both of them pointer to 0, else just decrement the rear pointer. So this is how the rear end deletion occurs. So let me show you the next example for this. So this is my Q, 20, 30 and 40 are there. If I want to delete 40, what happens? This is the rear end deletion, students. So you just need to decrement rear end. Okay, so rear will be there, the 40 will remove. Again, see the deletion operation. Again, rear will be decremented and 30 will gone. Again, the deletion operation. What happens? After deleting 20, the F and R at the same position, so Q becomes empty, and when the Q becomes empty, my F and R both pointing to 0. Fine. So here it is. After when the F and R at the same position, I just need to remove the 20 from here and F and R to 0. Okay, this is how my Q becomes empty. This is the deletion algorithm of deletion at rear end in DQ. Now, let me show you the example how they in exam they asked you. So this is the example, students. You just need to write down the position of front and rear, but make sure where to insert, where to delete. Okay. So this is my Q. Very first Q here I have like dash 15, 25, 45 and dash blank. My front pointer is at 2 and the rear is at 4. My Q size is 6. What happens? So this is the beginning. This is the beginning. You just need to make a table like this, like operations, front, rear, and Q. Okay. Here my latest beginning. At the beginning, my front is at 2, rear is at 4. Now let me check the various operations from here. The first one is insert at front end. Insert at front at 22. I want to insert at front end. The value is 22. Okay, fine. Insertion at front end. Is that normal? No. So here we just need to decrement your front pointer. Just check out the front pointer value. It's 2. So then just check out the front pointer value. Is at 2. So you can decrement your front pointer. Yes. So just value becomes 1 and here is at 4. The value is inserted 22. Now the next is insert rear 42, and we need to insert 42 at the rear end. Is the normal thing? Do we have the enough space at the rear end? Yes, because Q size is 6. Here the right now the rear is pointing at 4, so we can at least insert 2 elements. Okay, so here we can also insert 1, 5 and the element is inserted. Fine. Now what happens? The next step is insert at front 34. See, my front pointer value is at 1. Okay, now can I, students, decrement my front pointer? Yes or no? No, because front pointer is already at 1. You cannot decrement it more for the insertion. Because the Q is overflow, students, you cannot insert 34 over there. 1 and 5 remains as it is. All my Q is full only for the DQ insertion at front end condition. My DQ is full. Next, insert at rear, we can insert 54, rear will be incremented, goes at 6. Next, deletion at front. Deletion at front. Okay, so you can delete at front. You can perform the deletion operation at front. Yes. Okay, so just do it. Delete the latest value is 22. Okay, so 22 will be deleted. So 26, front will be incremented. Next, we have delete at rear. Yes, students, you can perform the deletion operation at the rear. For that, you just need to decrement the rear pointer. Decrement the rear pointer, which becomes 54. 54 will gone. Rear becomes 5 again. So here it is, my answer. Next, we have the deletion at rear. Rear again decremented. It will become 4 and 42 will be deleted. Next, we have insert at rear. Insert at rear 65. We have enough space for the rear end. Yes, so rear will be incremented. It goes 5. So the 2, 5 and 65 is inserted at the last. So this is all about the example of the DQ insertion and deletion, which you can apply easily by applying the algorithms. So that's it for the DQ algorithms. We have seen the insertion at delete, insertion at front, deletion at delete and deletion at front. Okay, so if you have any doubt, just feel free to ask me. Thank you so much.